Dear cadets, Assalamu alaikum. Welcome you all at my online class. This is Maqsudur Rahman, lecturer in chemistry, Borishal Cadet College, Borishal. It is very necessary to keep yourself inside home along with your family members for avoiding the running pandemic COVID-19. Considering prevailing situation, Borishal Cadet College is providing necessary academic guidelines and short lecture on a specific link periodically. For this continuation, I am here to take your online class. Okay, boys, by seeing this picture, that is iodometry, and another picture, iodimetry, what do you guess? Yes? Today, this is the last session of stoichiometric chemistry, chapter 3 for class 12. At the end of this lesson, you will be able to define iodometry and iodimetry titration, and you can also analyze acid-base titration curve. So first one is iodometry and iodimetric titration. In my previous lecture, I discussed on titration. You know that titration are based on a reaction between analyte and a titrant. What is analyte? Analyte is a substance that concentration is unknown to us. That's why it is unknown solution. It is called unknown solution. And titrant, it is a standard solution. What is a standard solution? The solution of which concentration is known to us is known as a standard solution. The quantity of the analyte can be determined if we know the reaction and volume or mass of the titrant needed to react completely with the analyte. So by knowing the amount of titrant, that means knowing the volume of titrant or mass of the titrant, we can determine the volume or concentration of analyte. And iodine can be used for this redox reaction titration, as it has capacity of reacting fast with many species. That's why iodine is used in case of redox titration. So iodometry and iodimetry are two common titration methods used in analytical chemistry. So now, what is iodometry titration? In iodometry, iodides are allowed to react with another oxidizing agent, that means analyte, in an acidic medium or neutral medium. Here you can see that at first analyte is react with iodide solution. That's why we get iodine. When this reaction takes place, iodide will be oxidized to iodine, and this analyte will be reduced by iodide. And as this iodine, then this released iodine is then titrated with reducing agent, that means standard thiosulfate solution, and we get product. So as this is standard solution, that means its concentration is known to us. So by calculating the volume or amount of titrant, we can find out the volume of iodine. And if we find the amount of iodine, we can find the amount of analyte. So we can say that iodometry is indirect process to find out the concentration of analyte. Here is an example for your understanding. When copper 2+ react with iodide, we get iodine. This iodine, when titrated with sodium thiosulfate, we get products. And this, as this thiosulfate solution is standard, that means its concentration is known to us. So by calculating the amount of thiosulfate, we can find out the amount of iodine. And if we find out the amount of iodine, we can also find out the amount of copper 2+, that means analyte, and its concentration is unknown. So by find out the amount of iodine, we can find out the concentration of copper 2+ ion. So we can say that in iodometric titration, this is two-step reaction, and it is indirect process to find out the concentration. Now, what is iodimetric titration? When a reducing agent, that means analyte, is titrated with iodine, this method is called iodimetry. Therefore, iodine will be reduced to iodide and other species will be oxidized by iodine. So this is one step reaction, or you can say this is direct reaction. So when analyte react with iodine, we get products. So as iodine, concentration of iodine is known to us, we can directly find, if we find the volume of iodine, we can directly find out the concentration of analyte. So we can say that this is direct titration method and it is one step reaction. Here is an example for your better understanding. We know that in vitamin C tablet there is ascorbic acid. So if we want to find out the amount of ascorbic acid that is present in vitamin C tablet, we can titrate with iodine. You can see this is the structure of ascorbic acid, and when this ascorbic acid react with iodine, we get dehydroascorbic acid. So iodine rapidly oxidized ascorbic acid and to produce dehydroascorbic acid, and if we find out the amount of iodine, then we can find out the amount of ascorbic acid that is present in vitamin C tablet. So by titration with iodine, we can easily find out the concentration of ascorbic acid that is present in vitamin C tablet. This is the application of iodimetric titration. So in iodimetric titration, a solution of unknown concentration is directly titrated with an iodine solution. So we can say that in iodimetric titration, there is a reducing analyte, this is unknown concentration, and this is one step reaction, and we use iodine as a standard solution. By knowing the concentration of, or knowing the amount of iodine, we can find out the concentration of unknown solution. So this is direct process and it is one step reaction. And in iodometric titration, so unknown concentration solution is titrated with iodide solution, and the released iodide is then titrated with thiosulfate solution. So this is two-step reaction, and unknown concentration solution is, if to find out the concentration of unknown solution, at first this solution is treated with iodide, then the released iodine is treated with thiosulfate. So if we find out the amount of standard solution, that means sodium thiosulfate solution, then we can find out released iodine, and this released iodine will say the concentration of unknown solution. So this is indirect process and two-step reaction. So therefore we can say that iodimetry is a direct method and iodometric is indirect method for find out the concentration of unknown solution. Now, reaction of acids and bases. When acid and base react with each other, we know that it forms salt and water, and this reaction is known as neutralization reaction. So what is neutralization reaction? When acid and base react with each other and form salt and water, this reaction is called neutralization reaction. Here you can see that hydrochloric acid, when react with sodium hydroxide, we get sodium chloride and water. This is acid, this is base, and we get salt and water. So we can say that when acid and base react with each other, we get salt and water, and this is neutralization reaction. Now we discuss on titration curve for strong acid and strong base reaction. When strong acid react with strong base, it forms salt and water, and this reaction is very swift and also complete. At the end of this reaction, if moles of base equals to moles of acid, number of molecule of acid and base exist as every molecule in the reaction has completely reacted to form salt. So hence the end point or equivalence point is precise and sharp. So in case of strong acid and strong bases, if we use equimolecular moles of base and equimole of acid, so acid and base react with each other and it completely converted into salt, and in that case the end point is precise and sharp. So example of strong acids are hydrochloric acid, sulfuric acid, nitric acid, chloric acid, phosphoric acid. This is perchloric acid. The example of strong base, sodium hydroxide, magnesium hydroxide, aluminum hydroxide, etc. So if you see the reaction, here hydrochloric acid react with sodium hydroxide, we get sodium chloride and water molecule. So this is the complete reaction, and for this reaction the end point or equivalent point is precise and sharp. Now we observe in this figure, you can see that either the known quantity of acid is taken in burette to react with an unknown quantity of strong base in the flux or beaker, vice versa. That means if we take acid in burette, we can take base in flux, or if we use base in burette, we can take acid in flux. And if we do the titration, then the pH of the end point is neutral, because when strong acid and strong base react with each other, the salt that is formed is totally neutral and its pH is 7. So we can find out the neutralization point or end point at 7. And this graph is very precise and sharp. We can easily understood the end point of the reaction. By seeing this curve is very sharp and precise. So we can easily find out the neutralization point. And here the neutralization point is 7. And any indicator can be used to determine or indicate either a substance complete or acid become remain or base become remain. So any indicator, for example, phenolphthalein, methyl orange or methyl red, you can use for the titration of strong acid and strong base. Now, if strong acid is titrated with weak base, what do we get? Considering hydrochloric acid as a strong acid and ammonia solution as a weak base, what is the reaction? Here you can see that ammonia is a weak base, react with a strong acid, hydrochloric acid, and we get ammonium chloride. So here you notice that one is weak base and one is strong acid. So what is the titration curve for this reaction? So as a strong acid is titrated with a weak base, the end point occurs at pH less than 7, because when weak base react with strong acid, this salt is slightly acidic in nature. That's why its pH is less than 7. Its pH is less than 7. We can find out the end point here is less than 7. And therefore the most suitable indicator is methyl orange or methyl red, because methyl orange or methyl red change its color if the medium is slightly acidic. So here ammonia and hydrochloric acid react with each other and form ammonium chloride, and this salt is slightly acidic in nature when dissolved in solution. So its pH changes below 7, and equivalent point we find below 7, and in that case we use methyl orange or methyl red as indicator. Now if we use weak acid and strong base, what will be the titration curve? Here if we take ethanoic acid, this is weak acid, and sodium hydroxide, this is strong base. So this is ethanoic acid and sodium hydroxide, if react with each other we get sodium ethanoate and water. So as this is a weak acid and this is a strong base, the end point occurs at pH greater than 7. Here you can see that the end point is greater than 7. Here you can see the end point. So the most suitable indicator to use is phenolphthalein. You can use phenolphthalein because it changes colors in this when pH is greater than 7. So if weak acid is titrated with strong base, we use phenolphthalein as indicator, and titration curve is like this, and we can find the end point is above of the 7. Now, if weak acid is titrated with weak base, if both are weak, then what will be the titration curve? The common example of this would be ethanoic acid and ammonia. You know that ethanoic acid is weak acid and ammonia is weak base. So we get ammonium ethanoate. Here both acid and both base are weak. So mostly they are avoided due to imprecise endpoint. So we cannot find the precise endpoint. Here you can see that this endpoint is not precise and sharp. So it is very difficult to find out the endpoint because both acid and base is very weak. So at the endpoint, the pH will be 7 theoretically, but not we find the endpoint, but cannot be measured precisely like that in strong acid and strong base. So in strong acid and strong base, we find the sharp and precise curve, but in case of titration of weak acid and weak base, we cannot find the precise or sharp curve. So this equivalent point is 7. It is theoretically, not we can find it practically. That's why you can say that the titration curve for weak acid and weak base is not precise. So today we learned about iodometry and iodimetry titration and titration curve for different acids and bases. So if you have any question, please write it in the comment box. I will try to clarify it. And here is a home task for you. First question, what is the difference between iodometry and iodimetry? Why phenolphthalein indicator is used in acid-base titration? Why is iodine solution kept in dark? What is endpoint in titration? And what is equivalence point in acid-base titration? You try to solve these questions. So thank you very much for your participation. I want to say you that you must stay at home, wash your hands regularly, maintain social distance, make conscious your family members, avoid novel coronavirus COVID-19, make your lesson and make the best use of your time. Thank you very much.